Alright, so let's now look at the Flatmap method. Now we've already seen map, which can transform one object. So that takes a function as an argument, which takes one object and returns a value. So we may want to map a single object to more than one object. And we can use the Flatmap method to actually achieve that. The method accepts a function that returns a stream value. So we can pass an object as the function argument and return a string containing several objects, which means that we're effectively mapping one object to many. In fact, that's the intended use of the Flatmap method. Let's take a look at an example of using that. So we're going to add a couple of classes to our project. So I'm going to create a new class, employee, and you can create them either as separate files or just add them to the main Java file. I'm going to create them as separate files, employee. And this employee is obviously the one that we've used in the past, so I'm just going to copy and paste the code so you can refer to that previous definition for employee. We just had the string name and an int age, but what we are going to do is we're going to add a toString method there just to be able to print out the name. So we're going to just override that toString, and we're going to return our name. So that's the only change we're making there. All right, the other thing we're going to do is add another class. We're going to call this one department. So this is a new class, so we're going to create a string first, private string name to be the name of the department. Then we're going to have a private list employees, so obviously the employee is attached to a department. We need a constructor which accepts the name of the department as a parameter and will initialize the list as an array list. And we'll accept that import. And we want an add employee method, so public void add employee, which accepts an employee, and then adds it to our array list, employees.add employee. Then we also want get employees. Employee, get employees, return employees. All right, so going back to main now, we've created both of those. So let's create a few employees and add them to a couple of departments. So employee John equals new employee John Doe 30. We'll do Jack for the next one. Actually, like the next one, Jane. We'll make the one after that Jack. And Jack will set to be 40. And Jack Hill. Last 22. Snow White. Okay, then we'll do department. HR equals new department. We'll call that one human resources. Then let's do a HR.add employee. We'll add Jane first to HR. HR.add employee. We'll also add Jack and Snow White there as well. HR.add employee Snow White or Snow, and create another department. So department accounting equals new department accounting, and HR.add, sorry, accounting.add employee John. Okay. So now that we've done that, let's suppose that we want to print all the employees that work for the company. So we're going to start by creating a list called departments and add both our departments to it. So list of department objects, department, we'll call it departments equals new array list. Then we'll do departments.add HR departments.add accounting. Alright, so that's all our departments. And of course we could add a get employees or print employees method to the department class and then iterate over this list and print the employees. But because we're working on streams, let's use streams and have a look at how the Flatmap method might help us do that instead. We can do that with departments.stream.flatmap. We're going to do department, and notice I've got the option here, department. I can press enter for that first declaration like so, and then for the expression I'm going to put department.getEmployees.stream, and then use a dot for each. So for each, and the system.out ::println. And that's how concise it can be. So let's actually run this to see that it works. And there's our 4 employees. So you can see that the Flatmap method wants a function that returns a stream. Now each department in the source stream becomes the argument to the function. For each department, we call the getEmployees method, which returns a list, and then we call the stream method on that list to return a stream of employees. Now the items in this stream are added to the stream that will be returned from the Flatmap method. Now in the case of the HR department, we've gone from 1 department object to 3 employee objects. The method is called Flatmap because it's often used to flatten nested lists. Now in this case, there are lists of employees nested within the department list. So the Flatmap method is the one to use when we want to perform operations on a list, but the list isn't the source. So an object containing the list is the source in this scenario. And we use the method to create a stream of all the objects in those lists. Now another handy method is the collect method. Now this is a terminal operation. So it collects the elements in a stream into a different type of result. For example, we can add all the items in the stream to a list or set. After all, unless the purpose of the chain is to produce a list of items to print, we'll usually want to save the result somewhere. Now you might be using streams to selectively reduce and sort a large list because you may want to use the reduced list in subsequent code. So we'd use the collect method to create the reduced list. So let's say that we wanted to save the result of our first example where we uppercased, filtered and sorted bingo numbers. Now instead of printing the list, we could call collect, the collect method, and store the contents of the stream at the end of the chain into a list. And then we'll print the items in the list. So let's actually rewrite that code to do that. Do list string sorted G numbers equals, and it's going to be some bingo numbers dot, start off with dot stream, then we want to do a dot map string : to uppercase because we're converting the results to uppercase. Then we want to do a filter, and remembering we use a predicate here to get all the ones that start with G, so it's going to be S as the parameter, arrow token, S dot starts with G in uppercase. We want to do a sort, so dot sorted, and here's the extra bit, so it's dot collect, and notice when I did that it automatically added the collectors.toList for us automatically. And once we've done that, on the next line we can then put something like for string S : sorted G numbers and print out the value. And just before we do that, let's actually put something here just as a separator. Alright, so let's actually try running that. And there's our G numbers. And this is just telling us, by the way, that it could be replaced with a for each, which we've discussed previously. Alright, so we got the same result as last time, but the difference here is using the dot collect is that we have a list that we can continue to work with if we wanted to. Now there are 2 versions of the collect method. One accepts a collector, which is an interface to the java.util.stream package. Now underneath the covers, this version of the method maps the collector to the arguments required by the second version of the method, which accepts, or expects rather, 3 arguments: a supplier, a by consumer accumulator, and a by consumer combiner. So these arguments let us be specific about how we want the items to be added to the result of collect, the collect method. For example, let's say we wanted to end up with an array list rather than a list. We can use the more specific collect version of the method to actually do this. So let's just take a copy of this, and I'm going to just comment that out. So we've still got the code there. And I'll paste that back in, and let's actually make a change to that. So the stream, the map, and the filter, and the sorted is all the same. The .collect is what we can change, and we can do that here. By changing this out, I'm going to delete that. And we're going to put array list, ::new, comma, array list, ::add, and array list, ::add all. So on that line 79, the first argument to collect is the supplier. Now if you recall, a supplier creates objects. Now we want an array list, so we pass the array list ::new as the supplier, which will construct a new array list for us. By the way, when passing method references, we use the name of the class, array list in this case, ::new, when we want to pass the constructor. Alright, so moving on, the accumulator is the array list .add method. That's how we'll add the items to the array list. And finally, the add all method is the combiner. So the accumulator is used when the runtime needs to add a single version or a single item into the list. The accumulator is used when the runtime needs to add a single item into a result. The combiner is sometimes used to improve the efficiency of the operation. If and when to do this is really up to the Java runtime. Now there are many APIs that we can map to the supplier, accumulator and the combiner, and this allows us to do all sorts of things using collect. For example, if we had a lot of employees and there are groups of employees with the same age, we could create a map of lists based on age using the collectors.groupingby method. Now I won't actually do this, but I'll just show you what the code would look like. It'd be something like map integer list employee and grouped by age equals departments.stream, and it'd be something like Flatmap, and it would be departments and then add the arrow token, and it'd be department.getEmployees.stream. We're getting the list of employees for that department now, and then it would finish that off with a .collect, and we'd do something like collectors.groupingby, and we'd do employee accept that import, employee arrow token employee.getAge. So that would allow us to do that. Alright, so the last method that we're going to look at now is the reduce method, and that combines all the items in a stream into a single result. Now there are actually three versions of this object. We're going to take a look at the simplest one, which reduces a stream to one of the elements in the stream. For example, if we wanted to use a stream to find the youngest employee in the company, we do something like follows here. So it'd be departments.stream and .flatmap, then department as the parameter, and then arrow token department.getEmployee, or employees I should say, .stream. Then we use .reduce, and the .reduce would be, we'd need two parameters here, E1 and E2 for the employees. Arrow token E1.getAge less than E2.getAge, using a ternary operator here, so, and then with question mark E1 if the value is true, and then E2 if the value is false. And then if present, and we're going to do system.out ::println. So here we're using the version of reduce that accepts a by function, which if you recall expects two arguments and returns a result. Now this function compares the ages of two employees and returns the younger employee. So the result of the reduce method will be the youngest employee in the stream. Now we use the if present method on line 93 to print the result, because this form of the reduce method has an optional result. The reduce method is a terminal operation. So the call to if present isn't part of the stream operation chain as such. Here we're just chaining a non-stream method call onto the stream chain result. So if we run that, you can see we've got the answer Snow White, and if we have a look at our numbers again, we can see Snow White in this case was the youngest employee. Alright, so a few notes about streams. Firstly, we can't reuse them. Once we've called a terminal operation on a stream, we'll receive the illegal state exception if we try to operate on that stream again. Operations in streams are lazily evaluated. So what that means is that intermediate operations are not performed until there's a terminal operation. And I'll look at an example of that shortly. Also, we can use more specific stream interfaces when we're working with lists of numbers. So int stream, long stream, and double stream, for example. Now these interfaces have additional methods like sum, min, max, and a few others that are useful when working with numbers. Now there's also parallel streams, which we use when we want to increase performance by executing streams in parallel. Now whether you needed to do that would be really dependent on your application. Parallel streams are really outside the scope of this section though. I just really want to point out that we can get a parallel stream from a collection though by using the parallel stream method. Alright, so I mentioned that operations in streams are lazily evaluated. Let's look at that in a bit more detail. And I'm going to create here a list of create a stream of strings and filter them. So I'm going to do stream.of ABC, stream, not steam. So ABC, AC, BAA, CCCC, XY, ST. Then we're going to do dot filter. So S is the parameter, and then arrow token, code block. We're going to print out S, and we're going to return S dot length is equal to 3. Now if you recall, the filter method accepts a predicate which takes one argument and returns true or false. So there's nothing stopping us from doing other things inside the predicate. Now in this case we're printing the argument that's passed to the predicate, but when we run, you can see we've got nothing printed. The last thing printed was the Snow White code from line 93. Why didn't we get anything printed here? Well, it's because stream operations are lazily evaluated. In other words, nothing happens until there's a terminal operation. Now, there isn't a terminal operation in this chain, and that's why it was not being evaluated. And when you think about this, hopefully it makes sense though. If we have a long chain of intermediate operations but no terminal operation, then there's nothing coming out the bottom of the pipe, so it would be a waste of time to execute all the intermediate operations. So let's actually add a terminal operation to the chain. So I'm going to come back here and put a dot count, count like so. So now if we run that, we get our answers. And we're actually seeing the argument to the predicate printed out on the console. Okay, so before I close off the discussions on Lambda expressions, I want to talk a little bit about best practices. Now, throughout this section, I've intentionally written Lambda expressions in different ways. Now, here are the variations that I've used. First one was specify the types of parameters versus letting the compiler infer them. The second one was using a return statement with curly braces for one statement Lambda expressions versus not using return because it's implied and hence not requiring curly braces. 3, using Lambda expressions that contain one statement versus Lambda expressions that have more than one statement. And 4, using parentheses with a Lambda expression only has one argument versus not using parentheses since they're optional when there's only one argument. So if you look at the 4 variations, the 2 alternatives offer the choice between verbosity I should say, versus conciseness, which in turn often comes down to the choice between readability and conciseness. Not all the time, of course. Short Lambda expressions are usually readable no matter how concise they are, but when striving for conciseness, we can sometimes write Lambda expressions that are difficult to decipher because we've left out too much information. Now, there are a number of articles and tutorials on the internet that discuss best practices when using Lambda expressions. Now, many of them fall on the side of conciseness, but keep in mind that best practices are guidelines, not rules. So when reading code that I haven't written, or going back to code that I wrote months or years ago previously, it's actually not unusual for me to come across a Lambda expression that's cryptic and takes a lot of work to figure out. So the question I would ask is, was it concise? Well, yes it was, but was it readable to the human? No. So yes, we can optionally leave out the parameter types when the compiler can infer them, but will it be easier for a developer reading the code to do the same? Now, we don't have to include the return keyword when a one-statement Lambda returns a value, but will a developer be able to tell at a glance that the Lambda expression returns a value? So in my opinion, when it comes down to practices that are syntactic and don't make a difference to the code that's generated, the key thing here is to be consistent. So don't use different styles within the same file. If you're working on code someone else wrote and they always leave out the parameter types, then you should do the same. And if they always use the return keyword with one-statement lambdas, do the same. If you're writing code from scratch, do what's clearer and the easiest for you, and also what you think will be clearer for other developers who may work on the code in the future. Personally, I'd rather see a verbose Lambda than a concise one with a comment, because I know from experience that comments aren't always updated when the code is, and that can ultimately lead to a lot of confusion and wasted time. Alright, so that's it now. I'm going to finish the video here now. In the next one, we're going to start work on the challenge. So see you in the next video.